In this example, I'm going to be solving this exponential equation. And so when I look at that here, I see it's an exponential equation because my variable's in the exponent. Exponential equations are easiest to solve if you can get the same base on both sides. So I've got 2 to a power, that's my base on the left. On the right I've got 5 to a power. And unfortunately I don't know a way of rewriting 5 so that it's 2 to a power. So that's not going to work. The other way we solve exponential equations is we make use of the property of logarithms that says if I have the log of something to a power, I can bring the power down in front. If you have 10 to a power, you might want to take log base 10, which is a common log, or the LOG button on your calculator. If you have another base, especially e, but I don't have that here, we can take the natural log, and that's what I'm going to do. So I'm just going to take the natural log of both sides. So that's the ln. So ln of 2 to the 5x plus 7 equals ln of 5 to the x minus 1. And now what I can do is bring these powers down in front. What I have to be careful of, though, is that when I'm taking this power down in front, the whole power gets multiplied by natural log of 2. So to force myself to do that, I'm going to write the 5x plus 7 in parentheses. So 5x plus 7 times the natural log of 2, and then the same thing on the right, x minus 1 in parentheses times the natural log of 5. And now what's going to be important here is I'm trying to solve for x, and x occurs in a couple places. And so when that happens, I need to try to get my x's together in some way. The other thing that's messing me up here are the parentheses. So I'm going to distribute the natural log of 2 and the natural log of 5 on both sides. So that means I'm going to get 5x times the natural log of 2 plus 7 times the natural log of 2, and then x times the natural log of 5, and then negative 1 times the natural log of 5. But of course I don't have to write the 1. Again, I'm trying to solve for x. X is on both sides of the equation. I don't want that. I want x to be on only one side of the equation all by itself. If you have a case like this where x occurs in a couple different terms, the sort of trick we use is we start out by getting all the terms involving that variable x on the same side of the equation. So I'm going to want to move this x times the natural log of 5 over to the other side. So I'm going to subtract x times the natural log of 5 from the right, and then I'm going to subtract it from the left. And then see what I get. So I'm going to have still 5x ln 2, natural log of 2, minus x times the natural log of 5, plus I still have 7 natural log of 2, and then over here I'm just going to have negative natural log of 5. Trying to solve for x. So these two terms have an x involved. Right? These two terms have x's. This term doesn't have an x. The way this works out is I'm going to want to move then that term over to the other side. I want everything with x on one side, everything else on the other. So I'm going to subtract 7 ln 2 from both sides. So I'm going to have 5x ln 2 minus x ln 5 equals negative ln 5 minus 7 ln 2. The way this trick works now is I'm still keeping track of x I'm trying to solve for, but now all the terms on the left, both terms on the left have an x. That means x is a common factor. So I can factor it out. I make a set of parentheses and then I sort of play what's missing. You know, if I take out this x times what would equal what I have up here? Well, I'm missing the 5 and the ln 2. So I'm going to get 5 ln 2, and then the same thing with the second term, x times what equals that. I'm missing the minus ln 5. Almost done here. So now this is x times that set of parentheses. So to undo a multiplication, I just divide. So I'm going to divide both sides by 5 ln2 minus ln5. And those cancel over here on the left. So I'm left with x equals negative ln5 minus 7 ln2 all over 5 ln2 minus ln5. And that's my exact solution. And that's what we're told here. That's this first solution in terms of logarithms. Then I want to use a calculator to obtain a decimal approximation. Now, most calculators these days, we enter the calculation pretty much how it looks. And so what's important here, though, is when I'm going to be entering this solution on my calculator, this fraction bar sort of assumes that I have the whole numerator divided by the whole denominator. To make that happen, I'm really going to have to add parentheses around the numerator and denominator when I do this on the calculator. So again, for most calculators, what I'm going to need to do then is to force the calculator to do the whole numerator first. I'm going to have to put the whole numerator in parentheses. So I'm going to start with a parentheses button. Then I need the negative. To get the negative, don't use the subtraction button. You should have a negative button, which is like a little minus sign in parentheses. So that's what I do for that. And then I'm just going to take natural log of 5, and then minus 7 times, oops, I forgot something here. Let me go back. So we do that minus, and then we have natural log. When you hit the natural log button, in most calculators, it starts a set of parentheses. And if that does that here, so I'm right here, right? Negative natural log of 5. So I take the natural log of 5, but before I do this minus, I'm going to have to close that set of parentheses. So that forces it to just take the natural log of 5, and then minus 7 times natural log. And again, most of these calculators open a set of parentheses there. So you'll put in the 2. Now we have to close that set of parentheses. That's just doing this here. We also started this set of parentheses for the whole numerator. So I'm going to have to close that right here. So this now is the numerator that I have there. And I finish the problem then by dividing by the denominator. So divided by, put parentheses for the denominator. 5 times ln. It's going to start a set of parentheses. We put in 2. We finish that set of parentheses. Minus ln. It's going to start a set of parentheses. We put in the 5. We finish the parentheses. That's just the natural log of 5. I need to finish this denominator parentheses, so I'm going to put that, another set of parentheses, and then enter. Now, if you have a calculator that works sort of backwards, I'm calling that others here, with calculators like this, the natural log button works a little differently. I have to put what I want to take the natural log of first and then hit the natural log button second. You still want to put the whole numerator and denominator in parentheses. So I'm going to start a set of parentheses. Now, for what I'm doing here, I want to take negative natural log of 5. The way to get a negative on these other calculators is to use the plus or minus button, but that has to come after you've got the number in the display already. So to do this, I'm going to have to actually start with the 5, and then I'm going to hit the natural log button, and then I'm going to hit plus or minus. So 5, natural log. Your calculator now puts the natural log of 5 in your display, and then I hit the plus or minus button. That changes it to a negative number. So I've done this part so far. Oops, that's not what I wanted. I wanted that. I've done this part so far. Now I need to do minus 7 times the natural log of 2. So minus 7 times, to do the natural log of 2, I have to put in 2 and then hit natural log. And then I close the parentheses for the numerator. So that's what I have here. 5 natural log plus or minus, that gives me this, minus 7 times 2 natural log. The natural log takes the natural log of 2. When I do the parentheses, it does this multiplication and this subtraction all at once. Then I divide by the bottom. I need to put the bottom in parentheses. 5 times the natural log of 2, I do 5 times 2 natural log, minus the natural log of 5, I hit 5 natural log. I hit parentheses, that forces the calculator to do the denominator. However, this division is still hanging around in the calculator's memory. To make it do that, I have to hit equals here at the end. And no matter which way your calculator works, you should get an answer here of approximately negative 3.48 if you round to 2 decimal places. So you want to make sure you can figure out how your calculator works.